Welcome to Educan Community. Today we are going to start a new session on design and analysis of algorithm. So first of all, we are going to know about asymptotic notation. Then one by one, we'll know algorithm through recurrence relations, greedy algorithm, job sequencing problem, and many more. So today we'll start with asymptotic notation or asymptotic analysis. So actually what is asymptotic notation? So basically it's an idea that handles above issues in analyzing algorithm. So in asymptotic notation we actually evaluate the performance of an algorithm in terms of input size. So we calculate how the time taken by an algorithm increases with the input size. So basically we can say asymptotic notation are mathematical tools to represent the time complexity of algorithms for asymptotic analysis. So here now the three following asymptotic notations are mostly used to represent the time complexity of algorithms. So what are those? Number one is big O notation, and second one is big omega notation, and the third one is big theta notation. Now we will know what is big O notation. So if we draw the picture for big O notation, that will be it's a graph for big O notation. If this is f of n and this is c of gn and this part will be n0, then we can write for big O notation. Actual big O notation is we can say here a function fn is said to be order of gn that is denoted by a function fn is said to be order of gn that is denoted by f of n equals to order of gn is bounded above by some constant multiple of gn for all large n, that is there exists positive constant and non-negative integer. So positive constant and non-negative integer, that is denoted by n0, such that f of n less than equals to c into gn for always n greater than equals to n0, c greater than 0 and n0 greater than equals to 1. So then we can say f of n equals to order of gn. Okay, now what is big omega notation? So if I draw the graph for big omega notation, that will be like this. But this is the graph for big omega. Now if this will be f of n and this will be c of gn and this will be n0. So now we can say a function fn is said to be same as before, said to be omega of gn, that is denoted by f of n equals to omega of gn. If fn is bounded below, if fn is bounded below by some constant, below by some constant multiple of gn, constant multiple of gn, for all large values, for all large values of n, that is, if there exists some positive constant, and positive constant, it is denoted by c, and some non-negative integer, that is denoted by n0, same as before, such that f of n equals greater than equals to c into gn for n greater than equals to n0, c greater than 0, and n0 greater than equals to 1. So here then we can say f of n equals to omega of gn. Well, now we are going for big theta notation. Interestingly, big theta notation, we will draw the curve or the graph for big theta notation right now. So this is the graph for big theta notation. Now if this will be f of n and this will be c1 n, c1 of gn, and this will be c2 of gn. If c1 gn less than equals to f of n less than equals to c2 of gn for n greater than equals to n0, and c1 c2 greater than 0 and n0 greater than equals to 1, so we can say then f of n equals to theta of gn.